Hello, good afternoon. Mela. Ħanamel waħda l-attendance. Mela 3B. Okay. Mela. Matthew Aġus. Maġġiex. Janine.
Present.
Shallow cameras, please. Liam Block. Neck, alright. Kane Brinkat.
Present.
Mattia.
Present.
Christabel.
Present.
Martina Kutajjar.
Present.
Okay. Emily Desira. Ciao. Giulia Farrugia. Nathaniel. Keith.
Present.
Aiden.
Present.
Emily.
Present.
Okay, Nathaniel. Matea Nisevich.
Present.
Dylan.
Present.
Rajtu. Jacob Xkembri.
Present.
Okay. Luke. Reward hawnhekk. Luke Vella.
Present.
Rajnieh. U Jonathan Zammin.
Present.
Mela. Kejn u Jonathan ixgħalu ftit il-kamera, please. Okay. Mela. Emily ma daħlitx. Iva, hawnhekk Emily. Le, Emily Desira. Le. Alright, mela. Ħankomplu ir-revision li qed nagħmlu mela wasanna fit-topic ta' linear motion issa. Alright, fit-topic ta' linear motion. Mela bħalma t-namlu l-ewwel ħanurikom daqsxejn il-homework li konna t-namlu li għamilna l-dakinhar. Alright, mela. Il-first question was regarding vectors, alright? Ma kienx hemm affarijiet kbar, we had to draw the components there. 5 cos 30, 5 sin 30, mhux se noqgħod nagħmilha. And here you had these two vectors and you had to add them up to find the resultant of those vectors. That's what actually yesterday we added 5 or 6 vectors together. So the method to add them up was to open up the components. Alright, well għandek 50,000 cos 70, 50,000 sin 70, 10,000 cos 60, 10,000 sin 60, and then group the vertical together, group the horizontal, and use the parallelogram law. Mux se noqgħod nagħmilha għax għamilna waħda bħala l-ġimgħa l-oħra. Alright, let's start a little bit of problems regarding linear motion. Issa in linear motion, the first part regarded a lot the graphs. Alright, so we're going to revise a little bit graphs. So first of all, distinguish between distance traveled and displacement. What's the difference between distance and displacement, Isa? Isa? Difference between distance and displacement.
Distance can be shaped overall in a journey.
Okay.
Whilst displacement is how far you are from an initial point after the journey has ended.
Alright. Li ħanżid l għax tajba ħafna. Mela distance is the amount of meters covered in a journey, that's all. Displacement is how far and in which direction the object moved from one point to another. Alright? Ġveri, tittizit il-magnitude u d-direction, importanti, because displacement is a vector. Alright, ħanaraw daqxej il-graf. Mela, kena din il-graf. Okay? For a journey. It's a displacement time graph. It is a displacement time graph. So, if it is a displacement time graph, mela, ħanamlu daqxej bitċa xogħol. Ħanerġgħu niftakru ftit. Mela ħana rajna tlet tipi ta' graphs pratikament. Kenna displacement time graphs, kenna acceleration time graphs u kenna ukoll sena bisna l-iktar importanti. Kenna velocity time graphs u acceleration time graphs. Mela, ħampinġi graf sempliċi għal kull waħda. Musa noqgħod nidħol f'ħafna dettalji hawn. Ma nagħmel hekk ara. Ħalli nerġgħu niftakru ftit. Mela, tlaqna. Displacement time graph. Velocity time graph. Acceleration time graph. Mela, ħanaraw. Tlaqna. Mux hekk rid nagħmel. Daw mux hekk rid nagħmel. Hekk rid nagħmel. Ma jimportax. Okay, mela, ħanibdew displacement time graph. Moħna hawn, attenti. All right, Emily. Mela. Tajjeb. Okay, moħna hawn, all right? Mela, displacement time graph. What does the gradient represent for a displacement time graph? Velocity, tajjeb. Tinsewx, il-gradient huwa f'dan il-każ change in displacement over change in time mela jiġi velocity. The gradient of a velocity time graph jiġi change in velocity over change in time. It represents the acceleration. Issa, il-gradient ta' acceleration time graph ma nagħtux ħafna kasu. Għax dak jiġi the change in acceleration with the change in time. It gives you the rate of change in acceleration. At a level ma nidħlux dak id-dettall. Alright, kemm qed tinbidel l-acceleration. Avolja suppost fil-livell tagħkom għandkom tifmu, suppost tifmu għadi. Alright? How much the acceleration is changing per second, dak qed ngħidu. Okay? Imma ma noqgħodux nitru fiha. Issa. Okay. The area under the graph of a displacement time graph ittina xi ħaġa. X'tiġi l-area under the displacement time graph? Displacement times time ittina xi ħaġa? Le. L-area under the graph, jekk nagħmel area under graph, hawnhekk għandi change displacement time change in time. Issa velocity hija change in displacement over change in time. Ġifieri mhumiex l-istess qed tarhom. L-area under the graph ta' displacement time graph ma tina xejn. Kull ma tagħmel displacement times time ma tfisser assolutament xejn. Ġifieri l-area under the graph ħanamlilkom hekk ara. Area under graph ta' displacement time graph ma tina xejn. M'hemm xejn interessanti. Alright? Issa. Area under graph ta' velocity time, mela jekk insibu l-area jekk nieħdu square minn dik l-area ħadd tiġi velocity times time. Dik x'inhi velocity times time? Issa iva. X'tagħtina velocity times time? Displacement covered, very good. Okay? Mela area under the graph ta' velocity time graph importanti. Ħana rekkawx min jiftakara di. Area under graph of an acceleration time graph. Xittina. Ġveri jek neħu kaxxa żgħira ħanifmu. Għandek acceleration times change in time. Ek tiġi. Acceleration times change in time. Xittina l-area under the acceleration time graph. Għaw min jaf. Għamiltilkom ta' di weda fin-noti. Isa, provaw. Il-final minus initial velocity, very good. It's the change in velocity. Għax acceleration hija change in velocity over change in time. Mela change in velocity hija the acceleration times the change in time. Tarawa? Alright? So the area under an acceleration time graph gives you the change in velocity. Ġveri jekk issib l-area under the graph tkun tista' ssib allura kemm qiegħda tinbidel l-acceleration f'dik kemm qed tinbidel il-velocity f'dik il-biċċa. Okay? Now, if you have a curved graph in all of them, how can you find the gradient at a point? If you need to find the gradient at a point, what should we do? First, we draw what? Isa. Tangent. Then we take 2 points on the tangent, write the coordinates as usual, and then find the gradient. U l-aħħar ħaġa, if we need to find the area under a curved graph, how do we find the area under a curved graph? How can we do that? Tiftakru? Fil-physics, tgħidulix integration, tafu li ma nistgħux hekk ma jkunx il-formula. Isa, b'mod sempliċi kif nagħmluha to find the displacement, to find the area under a curved graph. Kif nagħmluha, Isa? Noddu l-kaxxi, nagħmlu estimation ta' kemm għandna kaxxi dawk li jkunu bil-biċċiet, u mbagħad times the area of one box. Times the area of one box. Alright? Mela attenti. So, namel di unkomplu. Mela the gradient of a displacement time graph gives you the velocity. The gradient of an acceleration time graph, namel di. Għalli nibqaw narawa here. The gradient of a velocity time graph gives you the acceleration. The gradient of an acceleration time graph di kien ħalwa barra. Avolja sens għalija. Area under graph of a displacement time graph, it gives you nothing. Displacement times time gives you nothing. Alright? The area under the graph. The area under the graph of a velocity time graph gives you the displacement covered. The area under the graph of an acceleration time graph gives you the change in velocity. Daw attenti għalihom. Daw huwa li tridu tistudjaw f'dawn, alright? M'hemmx ħafna iktar tistudja, alright? Daw l-affarijiet bażiċi, ħaninti kif dik it-tip ta' graf, tgħid alright, minn hawn nista' nsibek, minn hemm nista' nsibek u tmexxi. Alright? Dan kull ma trid tistudja, għax imbagħad skont jiddependi skont il-question. Mela, ħammorru għall-question li kellna. Mela, from the graph, determine the magnitude of the displacement of the object at the end of the 9 seconds in time interval. The displacement at the end of the 9-second interval. Mela, the displacement at the end of the displacement għalli mhux distance, the displacement. Mela, kemm huwa id-displacement at the 9-second interval? Isa, x'ħan għamlu? Kemm hu displacement at the end of the 9-second interval? 10 meters, that's all. Għax displacement tal-abni sewwa, mela 10 meters. Ħanara daqsxejn, li kieku saqsina determine the magnitude, determine the amount of distance traveled during the 9-second interval. X'konna ħanamlu? Biex insibu the distance traveled during the 9-second interval. Isa.
Add the distances walked.
Here's not the distances. Ġifieri f'dal-każ għandna. In the first 2 seconds, he moved 8 meters in one direction. Then, from C to D, he moved 8 meters back. Mux hekk tiġi. U rġajna morna at 0 meters, ġifieri għandna diġa A to 8. Then he moved from D to E, he moved 8 meters in the opposite direction, mela għandna 8, 8 u 8. Then from E to F, he moved 8 meters back. From F to G, he moved a further 8 meters in the original direction. Imbagħad minn G għal H, he moved a further 2 meters. Ġifieri, kieku talbek the total distance traveled kienet tiġi 8 plus 8 plus 8 plus 8 plus 10 kollox. Hekk kienet tiġi distance traveled. Ħaniktibha. Mela kieku talabna the distance traveled kienet tiġi 8 plus 8. Mela dik AB u CD. Mbagħad plus 8 DE, EF plus 8. Mbagħad minn F għal G u minn G għal H b'kollox għandek 10. Alright? Ġifieri prattikament kienet tiġi 42 meters. That is the total distance traveled. Araw kemm hi differenti. Ġifieri displacement at a time hija the distance from the reference point to daqshekk. Dak li għandi fuq il-y-axis infatti. Imma li kieku għallek the displacement traveled kien jiġi dak kollu. Alright? Issa, u li kieku saqsik, ma saqsik xaw, imma li kieku saqsik, le, xejn, ħani qafsem, alright. Mela, number 2. At what times did the object return to the starting position? At what times did he go back to the starting position according to this graph? Attenti, a displacement time graph, at jurini displacement. Isa. Għalli ma puntijiet jirreferi għaw. It has returned to its starting position. Isa, come on. Come on. F'liema punti mar lura fil-starting position? 5, 6.5, iva tajjeb, daqshekk dawk huma. Meta jerġa' jiġi hawnhekk, ara, meta id-displacement jiġi 0, mela qabel ma niktibhom. Ejja nippruvaw impinġu kif kont nagħmlilkom fil-lezzjonijiet. Let's try to draw the journey. So we started at the starting position. Issa the starting position jiena ġieli semmejtilkom reference position, u ġvera. Jew reference point. Because it's the point from where you are measuring your displacements. Mela bdejna at A at the starting point, għaliex għax huwa 0. At B the displacement is plus 8. So it's 8 meters. It's 8 meters in this direction. Hekk jiġi AB. Alright? Then BC, x'għamel BC? B kien 8 meters. C huwa 8 meters. So what's happening between B and C, Isa? What's happening between B and C? Stationary. The object is stationary between B and C. Għaliex il-displacement baqa l-istess. Then, between C and D, at C the displacement is 8, at D the displacement is 0. So what's happening between C and D? Come on. Issa, ħadmu moħkom. X'qed jiġri between C and D? What's happening to the object? C, the displacement is plus 8. At D, the displacement is 0. Miexi lura. Displacement 0, ġifiri, ġejna fil-starting position. Ġifiri, at D, we are back at the starting position because the displacement is 0. Tinsewx kif jitkejjel il-displacement from the reference point to the present position. So if the displacement is 0, means that you are back at the stationary point, at the starting point. So between C and D, the object is moving back. Issa, DE. At E, the displacement is minus 8, so it's 8 meters to the left, u xek. Mela ġejna għaw. Mux ġejna għax l-ewwel darba li għedin hemm. DE, 8 meters to the left. So the vector is pointing to the left. EF, Minn -8 rġajna ġejna F, rġajna ġejna 0, ux vera. F rġajna ġejna 0, so the object is moving from E, is moving back. Anzi, mux hemm ħanamilha. Għallin kon nista' nkompli nuri. From E to F, we moved back to the starting position. F to G, F at 0, G at +8. So at G we are back at that position. And from G to H, we further moved, and now the displacement is 10 instead of 11. Mela Lu instead of 8. Mela issa G 10. So H is there. So he continued on moving towards that direction. Alright, minn G għal H. Dik hija il-ġerni li għandkom hawn. Dik hija il-ġerni li għandkom hawn. Okay? Mela at the starting position kien at position A, ovvjament, 0 seconds, but it returned at D, li hija 5 seconds, and at F, li hija 6.5 seconds. Number 3. Which part of the graph represents the object at rest? How far is the object from the starting position during this time interval? Di tkellimnija. The object is at rest in this part. Alright? Why? Because at B he has at 8 meters displacement. C, he's at 8 meters displacement, so he didn't move. Mela, BC, the object is at rest. Issa għaljew how far from the starting point. At B and at C he is 8 meters to the right of the starting point. Infatti qed nitkellmu fuq dil-biċċa meta baqa' fl-istess punt għal dawk iż-żewġ sekondi. Issa 4. Use the graph to calculate the velocity of the object in sections AB, CDE, EFG and GH. Ġifieri pratikament qed jitkellem fuq l-slanting parts kollha. Alright? Fuq l-slanting parts kollha. Mela ħanibdew AB, CDE, EFG u GH. Dawk huma rridu nsibu l-acceleration, l-velocities u talabna the velocities. Mela, since this is a displacement time graph, how are we going to find the velocities? Għadna kemm iddiskutajnija. Billi nsibu xiex. Kif ħansibu l-velocities? Come on. Għadna kemm għadnija. If this is a displacement time graph, how are we going to calculate the velocity? From the gradient. Mela tlaqna. Ħanibdew B. Issa jiena dejjem nissuġġerixxi, alright? Dejjem nissuġġerixxi li timmarkaw il-coordinates taħdmu minn hemm. Għaliex? Biex hekk positive u negative signs jiġu awtomatiċi. Alright? Għax inkella ma jiġux awtomatiċi u nibdew inħawdu. Mela, the coordinates of point A huma 0, 0. The coordinates of point B huma 2,8. Oh, 2,8. Mela l-gradient ħajjiġi 8 minus 0 over 2 minus 0 li jiġi 4 meters per second positive. So the velocity is pointing towards the positive side. Ħanimxu għal CDE. Mela, at C il-coordinate hija 4,8. At D, le għasandi bżon id-D, għax CDE, nieħu E, għax nieħu the furthermost points. Mela at E, the coordinates are 6, minus 8. Mela l-gradient ħajjiġi, mela ħanamel minus 8 over 6 minus 4. Alright, mela jiġi minus 8 meters per second. Minus 8 meters per second. That's the velocity CDE. Velocity issa EFG. Mela, Il-coordinates ta' I nafa, il-coordinates ta' G hija 7,8. Mela għandna gradient ħajġi 8 minus 8 over 7 minus 6. Mela ħajġina 16 meters per second. That's the velocity for EFG. And finally, the velocity for GH. Mela, G, we know the coordinates already. H, the coordinates are 9,10. Mela, gradient ħajjiġi 10 minus 8 over 9 minus 7. Alright? Mela 10 minus 8 over 9 minus 7. U jiġina 1 meter per second. Dawk huma l-velocities kollha li kelli hawnhekk f'din il-graf. Issa. Draw a velocity time graph that shows how the velocity of the object changed during the 9-second interval. Mela rridu mpinġu velocity time graph mill-informazzjoni kollha li għandna. Mela, l-ewwel ħaġa tinsewx li la talabna velocity time graph, we have to take into consideration the directions. So, velocity to the right is positive, velocity to the left is negative. Alright, ma nistawx ma nagħtuhiex kasa. Ħana rek tiftakrux daqsxejn. Mela għandna diġà l-informazzjoni tal-velocities kif huma minn hawnhekk. Mhix nibdew meta nkunu ħampinġu graf minn graf oħra. Mhix nibdew l-ewwel. Mill-x-axis, tajjeb, mill-time. Mela ħanibda nipprepara t-time. Mela għandna A, mela 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Le, ġit niżajra wisq, mela ħan irranġaw ftit. Mela ħana melek 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Ekk aħjar. Mela, A qiegħed hemm, B qiegħed at 2, C qiegħed at 4, D qiegħed at 5, E qiegħed at 6, imbagħad għandna F qiegħed at 6.5, G qiegħed at 7 u H qiegħed at 9. Biex hekk ikolli il-postijiet lesti ħalli issa nkun nista' nibda niplottja. Mela, x'nipplottja l-ewwel? Isa, minn x'nibdew l-ewwel? X'nipplottja l-ewwel? Tiftakru? Mela l-ewwel nippreparaw it-time. Imbagħad wara nippreparaw it-time, x'nipplottja l-ewwel? L-affarijiet li huma kostanti, f'dal każ constant velocities. Mela, naraw. All the velocities are constant here because the gradients, they are all straight lines, so we are not changing the velocity between the different parts. Mela, AB għandna constant velocity of 4. Mela, kemm jitla l-iktar? 4 minus 8, 16 u 1. Mela, ħajkolli nagħmel 16. Mela dak 8, dak 4. U n-naħa l-oħra minus 8. Mela tlaqna. AB għandna velocity of 4 and it's constant. Issa. BC għandna velocity ta' 0, ux vera BC? Tkellimnija. Għadna hija at rest BC. Mela BC għandna velocity of 0. Okay, komplejna. CDE għandna velocity ta' minus 8. CDE ta' minus 8 il-velocity. EFG għandna velocity ta' 16. Okay? U GH għandna velocity ta' 1. GH għandna velocity ta' 1. Insomma, xi ħaġa hekk irid jiġi. Now, we join the different parts of the graph. Issa attenti, if you have a graph where you have points and they are at an angle, imbagħad tiġbed il-line at an angle. Alright? Hemmhekk imma tkun ċara li jkollok a variable velocity. Ovvjament, a variable velocity. Għaw xi ħadd iridni nispjegalu xi ħaġa oħra b'daw il-graphs? Issa attenti, jekk itikom velocity time graph, il-gradient jirrappreżenta acceleration. Alright? Ara l-affarijiet jiġu differenti, imma meta niplotjaw minn graf għall-oħra dejjem hekk nagħmlu. Mela l-ewwel nieħdu ħsieb il-ħin, imbagħad impinġu dak kollu li għandna constant għax dawk jiġu horizontal lines u mbagħad naqdu. Alright, mela din tieqaf waqafna saw. Issa. Qabel ma nkompli naħdem għax issa diħlin fi projectiles, ħanaħdem domanda, di ma ħdimtix magħkom. Di kienet fil-worksheet infatti. Li hija din. U ħanaħdimha daqsxejn. Alright, flimkien magħkom, ħanara. Dawkum bat projectiles, alright. Mela. ħanaħdmuha. U hija fejn marruha? Hawnhekk. Dik. Alright, mela. Ħanibdew it-tieni parti tal-linear motion. Alright? It-tieni parti tal-linear motion, l-ewwel parti kienet bil-graphs. It-tieni parti bdejna nużaw il-formulas. Issa, formulas f'linear motion, ħanerġa' nfakkarkom għandna żewġ gruppi. Għandna il-formula jekk ikollok constant velocity. Alright? Mbagħad għandna l-formula jekk ikollok uniform acceleration. Dawk huma iż-żewġ tipi li jista' jkollok. Jekk ikollok constant velocity, liema formula nista' nuża? Isa. Jekk ikollok constant velocity u m'għandekx graph, liema formula nista' nuża? Isa. Come on. U għajja, mhux diffiċli. Liema formula nista' nuża jekk ikollok constant velocity? Għal
Distance on time.
Velocity equals distance on time. Għal ma tafux di. Alright? Għal ma tafux di. Issa, ġili niktbuha change in displacement over change in time biex ikunu daqsxejn iktar eżatti. Biss jekk tiktibha distance displacement on time u taħdimha biżżejjed. Jekk ikolli uniform acceleration, liema equations nista' nuża issa? Isa. Uvat. Mela tlaqna. Ejħa niktbu l-formulas tal-Uvat. Mela għandna V equals U plus 18. S hija U plus V times T on 2. V squared equals U squared plus 2AS. U S equals UT plus half AT squared. Jekk ma tafux din, liema formula tista' tuża f'constant velocity f'uniform acceleration għandna problema kbira. Alright, fġieħ kemm hemm. Daw l-affarijiet huma l-bażi ta' kollox, bil-forsi rridu nżaw minnhom. Mela, ħa nippruvaw naħdmu din id-domanda. Di konsibta f'pass paper antika. Moħna hawn. Għax tidher sempliċi ma mhijiex. A runner travels 100 meters in 10 seconds. Assuming that it takes the runner 1.5 seconds to reach the top speed, and that this speed is maintained for the rest of the race. Find the maximum speed, the average speed, the acceleration during the first 1.5 seconds. Mela, nippruvaw nifhmu daqsxejn. Mela għandna runner. And he's going to travel 100 meters. Thank you. Thank you. 100 meters in 10 seconds. Alright? Issa. It takes the runner 1.5 seconds to reach the top speed. Ġifieri fl-ewwel 1.5 seconds. Fl-ewwel 1.5 seconds, he's going to reach mela ħajitlaq minn 0 and he's going to reach the maximum speed. And the speed is maintained for the rest of the race. Ġifieri for the rest of the race li baqalu u ħajżomm l-istess veloċità. Okay? Find the maximum speed. Mela ħaġa li tinsib hija V. Mela, ħanibdew naħsbu ftit. In the first 1.5 seconds, what is the runner doing? X'in sejħula Isa? In the first 1.5 seconds, x'qed jagħmel ir-runner? Come on. Accelerating, very good. And in the second part, li kemm tiġi seconds, the second part? Jekk l-ewwel parti ħadet 8.5 seconds. In the next 8.5 seconds, we have constant velocity. Taqblu miegħi? We have constant velocity. And we need to find this V. Tgħidli mhux problema, jekk nippruvaw naħdmu fuq ewwel biċċa. Liema formulas nistgħu nużaw fl-ewwel biċċa in the first 1.5 seconds? Isa. Mela, Luvat's equations, tajjeb. Mela, Luvat's equations. Mela, for part A, ħanamlu hekk. U bat għandi part B. Mela, for part A, we have to use Luvat's equations. Why? Because he is accelerating. Mela, ħanaraw x'nafu x'ma nafux. So, U is 0. The final velocity of this part, we need to find it because that's the maximum velocity. Taqblu miegħi jisaw? The acceleration, we don't know it. The time, we know it, it's 1.5 seconds. Do we know the displacement for this part? In the first 1.5 seconds, the amount of displacement covered. Le, 100 meters hija kollha. 100 meters hija minn hemm, stanna ta' minn hemm sem. Hija kollha 100 meters, all right? So actually, we don't know the displacement traveled in this part, all right? We don't know it. Mela, ħammorru għal part B. In part B, the object is moving at constant velocity. So in part B, what formula can we use in part B? Għadni kemm għattilkom, Isa. What formula can we use in part B? Since he's moving at constant velocity. Tajjeb. The velocity, we need it. We need to find that. The displacement traveled, we don't know it in 8.5 seconds. But the time, we know it, 8.5. Innotaw li għandi daqsxejn ta' problema għaliex fl-ewwel waħda għandi U għandi bżonn V u naf T. U fit-tieni waħda irrid insib V għandi S m'għandix u għandi T. Ġifieri m'hemm l-ebda formula li għandi kollox u li għandi bżonn. Ġifieri kif tidher li kemm minn part A u kemm minn part B ma nistax insib the maximum velocity, which is V. But we are missing one of the informations. Which information we didn't use? Għattilkom li ftit tricky. Which information I didn't use? Il-100 meters. Kif nista' nipprova nuża l-100 meters? Dik hija jisa link bejn A u B. If I manage to use 100 meters in order to link part A and part B, then I would be able to find the velocity, the maximum velocity, which we reached at the end of part A and continued in part B. Isa, x'taħsbu li ħana kif nista' naqqadhom? Ħadmu ftit moħħkom. Nista' nagħmel? Mhix straightforward, m'hemmx metodu ovvju. Tittaħseb, that's all. Issa x'nista' nagħmel? Come on. Għandkom ħafna. Xattilkom dik il-100 meters mużajnijiex. Issa, come on. Xejn. Mela, hemm żewġ metodi. Jew nagħti isem lil din distanza, pereżempju nsemmiha S, ha. Jekk insemmi S di distanza kemm tiġi? Id-distanza ta' part B. Isa.
100 minus S.
100 minus S. Mela hekk nitfa' din S u di tiġi 100 minus S, innutaw, nkun nista' nuża two formulas with two unknowns, V u S. U nista' nsiba. Or else the other method is I can use part A to find an expression, mhux l-answer, an expression for the distance of part A, ħansejħilha SA. Nista' nuża part B biex insib expression għal SB li hija the distance traveled in part B, but then I know that SA plus SB should be equal to SA plus SB should be equal to 100 meters, le? U minn hemmhekk allura nkun nista' nsib għax ħajkolli SA in terms of V, SB in terms of V u not. Ġifieri għandna żewġ metodi, it-tnejn huma tajbin. Mela, li wieħed ħanuża? Ħanuża l-ewwel wieħed. Mela ħanamlu hekk ara. Mela the first distance ħansemmija SA. The distance in part B mela ħansemmija 100 minus SB. 100 minus SA. Għax dik SA, mela 100 minus SA. Biex ikun nista' nużhom. Ħanaraw. UVTS, il-formula hija S equals U plus V times T on 2. Mela ħanitfa' l-affarijiet, mela S hija SA, U hija 0 plus V li rridu nsibu, the time is 1.5 on 2. Therefore, SA is 1.5 divided by 2, mela għandna 0.75 V. Sawnek alright? 0.75 V. Sissa okay? Yes. Mela dik hija l-ewwel equation tiegħi. Mit-tieni waħda għandna V equals S on T. Mela V irid insiba S hija 100 minus SA all over time huwa 8.5. Okay? Mela minn hawnhekk jiena nista' issa nagħmel hekk. Stenna, le, kollu sew. Mela għandna 8.5 V equals 100 minus SA. And that's my second equation. Issa x'nista' nagħmel? Kemm nagħmel substitution, mhux hekk għandi two equations with two unknowns. So SA is 0.75 V, therefore hawnhekk ħajkolli 8.5 V equals 100 minus 0.75 V. Mela għandi 8.5 V plus 0.75 V is equal to 100. Okay? Mela ħajkonna 8.5 plus 0.75 ħatiġina 9.25 V equals 100. Mela V hija 100 division by 9.25. U l-answer jiġi 10.8 meters per second. That's the maximum velocity reached by this runner after the 1.5 seconds. Et tarawa ma kienitx faċli. Alright? U ġieli joħorġu daw it-tip ta' questions, mhux darba joħorġu. Ġieli toħroġ per eżempju trid issib il-ħin when two objects overtake each other. Per eżempju, għandek żewġ accelerations differenti and they want to overtake. The point when they overtake each other, the trick is that the distance traveled is the same, mhux hekk? The point where they overtake each other is the point where the distance from where they started moving is actually the same. At that point they will overtake għax il-bqija dejjem ikunu f'distanza differenti. Ġifieri, daw id-domandi attenti għalihom għax kultant huma domandi li jħobbu joħorġuhom f'linear motion. Għax billi jafu li intom tafuhom diġà V = Assonti u Luvazz nispera. Alright? Arra kultant jagħtukom daw it-tip ta' questions jidhru sempliċi, imma trid tħaddem ftit moħħok. Ma trid tħaddmuh moħħkom. Alright? Ġifieri f'dan il-każ, pereżempju, li ridna nagħmlu huwa tagħna informazzjoni fuq il-distances and we had to use it. Alright? So we can give a name for the first distance traveled in part A, part B can be given in terms of 100, u mbagħad minn hemmhekk taħdem. Attenti għax mhumiex faċli, daqshekk. Imbagħad il-B kienet find the average speed is very simple, total distance over total time, u nsibu l-average speed, u the acceleration during the first 1.5 seconds. Imbagħad faċli kemm insibu l-acceleration, ġifieri nużaw formula oħra tal-Luvazz and we find the acceleration. Dawk imbagħad kienu straightforward. Alright? Imma attenti għal daw it-tip ta' questions. Okay? Mela, ħallikom hawn għadha niltaqgħu l-aħħar lezzjoni ta' dil-ġimgħa u nikkaverjaw projectiles għada. Alright? Għada nikkaverjaw projectiles. Tajjeb? Okay? Mela, ħallikom hawnhekk. Narakom għada. Ciao ciao.
Okay, sir.
Ciao.